Let me show you some techniques to debug errors and exceptions in a .NET mixed mode application. Every application eventually has errors and exceptions in production. This is an area in which WinDBG is excellent at debugging. Let me show in this video some quick techniques on how to perform exception handling in WinDBG for a mixed mode application. Let me start by switching over to my remote machine. What I have on the screen is that I have launched WinDBG and I've launched an application which I have written specifically for this example. This application can raise exceptions as native, managed, or it can raise an exception that is raised multiple times. I will explain in this video what I mean by an exception that can be raised multiple times or relayed. The exception that I've programmed as native is a null reference exception, also known as a null pointer exception. This exception is raised originally as a null reference exception by the CPU. The exception is slightly different than an interrupt, but for this simplified explanation, imagine that the null reference exception is raised just like an interrupt. The operating system in kernel space then inspects the exception to mitigate it. Mitigation in this example is to relay this exception back to the running application in user space. If the application is a .NET application, then it gets to be a bit more complicated. The exception can be raised a second time as a .NET exception. So what happens is that the kernel raises the exception to the program, and then the program raises the exception a second time as a .NET exception. This all sounds a bit complicated. So let me show you each kind of exception that is raised with my sample application. The first kind that I'm going to try is the native exception, which is raised directly from the kernel. So if I press this button over here, I will get an exception which is a null reference exception in .NET. So let's see in WinDBG what actually happens. So this application is a .NET application. So if I go over to the command tab over here and I run print exception PE, the PE command is located within the SOS plugin. I have already loaded the SOS plugin into WinDBG. I have a video on this playlist to show how to load the SOS plugin, so go ahead and watch that video first. But once you have loaded the SOS plugin, just run PE to see exceptions. PE in this view shows that there is no managed exception on this thread. This is actually correct because the kernel has raised the exception and the program has accepted it, but it has not raised the .NET equivalent exception for this particular error. This is why it says no managed exception. We can still read the exception by running other commands. To simplify the analysis, I'm just going to run analyze-v. Now, analyze-v may take a while to run. I'll just fast forward the video until it has finished run. So analyze has finished run. Let's just scroll up a bit and see what the exception actually is. So if we scroll up, what we get is we actually get that the exception is an access violation. This is correct because a null reference exception is raised as an access violation. If we were to resume the application, .NET will then raise the equivalent .NET exception. Let's go ahead and resume the application. I'm just going to press F5. And we get the Microsoft.NET exception handler. I specifically did not write any try-catch in my application and I did not put any handler in the app domain. That is why this exception handling box appears. But this box appears because the native exception was raised into .NET. It was converted to a .NET exception and there was no handler for it. So the Microsoft.NET Framework exception handler appears. Now let's try raising a managed exception over here, which is an out of memory exception. But this time I will configure WinDBG to trap CLR exceptions so that we can see the exception being raised in .NET. So what I do is that I break into WinDBG and I just run SX over here. SX is the list of exception handling that WinDBG is configured to handle. WinDBG can either break into an exception, or you can just write a line or a notification, or you can just ignore the exception. What I'm going to do is I'm going to instruct WinDBG to enable breaking into the exception CLR. So SXE CLR. What this will do is now, if there is a CLR exception, it will break in WinDBG. Let's go ahead and resume the application and raise it. So if I click crash as managed over here, I will get a out of memory exception. Let's take a closer look at that exception. If I run PE over here, I will get an out of memory exception, insufficient memory to continue execution of the program. This exception is not real. There is no out of memory. I just wrote code to actually just raise the exception to prove that .NET exceptions really do raise twice. So this is a fake exception over here. All I did was just throw a new out of memory exception. But what happens is if you do ask WinDBG to trap CLR exceptions, you will get all .NET exceptions. Let's resume the application. And again, I will get the Microsoft .NET Framework exception handler because I did not put any try catch. It's pretty much the same as the native exception. When there is no .NET exception handler, you will always get this box over here. Even if it is a native exception, if it is raised as .NET, you will still get this box over here. It's a bit confusing. Even though it's a native exception, the box still appears. It's because it's being raised twice. Let's go ahead and clear it. For the final example, I'm going to show a relate exception, which is it is raised as native, and then when I resume, it will be raised a second time as .NET. So before I raise the exception, what I'm going to do is I'm going to instruct WinDBG to capture EH, which is the exception that is going to be raised the first time. Now, I can always just raise all exceptions over here, just configure WinDBG to break everything, but it's a bit too complicated, so I'm just going to put a few, which is, I'm going to put EH, which is the C++ exception handling. I'm just going to enable that, and then I'm going to trigger the exception, and we will be able to get both exceptions. So when I click the button, the first exception that is raised is the C++ exception. If I run PE over here, I'm going to get that there is no current managed exception on this thread. This is actually correct. I can actually analyze this exception with analyze -v. Analyze -v took a bit long to run, but we get an actual exception that is raised by C++. However, this exception is kind of weird. It is actually in the middle of throwing this exception to .NET to be converted. Now, there is an actual exception that can be read over here. We can analyze this, but a quicker way is actually to just resume the application over here. And what will happen is that we will catch the .NET version of it. So now if I run PE over here, I will actually get a better exception than the native exception because the meaning of the exception will be translated correctly. Now, the meaning of this exception is that there is an arithmetic overflow. And the reason is because I did something silly. I just allocated a buffer that was so large that it cannot possibly be allocated. So what happened was that the native exception is actually an arithmetic overflow in the allocator. And so that will bubble up and .NET will convert it to the proper system overflow exception. Now, technically, I can read the native part of it. It's just too tedious. I don't recommend doing that. If you do have a .NET exception that is being raised, just let it flow through and let it get converted to .NET. Because the .NET exception over here has a nice message, whereas the native exception, you kind of like have to decode into here what exactly was happening. It's a bit tedious. I would just recommend just reading the .NET version. Generally, if you have a mixed mode application, it might get a bit tricky to capture the exceptions, especially if you're using Visual Studio. If you're having trouble, just attach WinDBG and look at the exception list in WinDBG and just trap the exceptions using the exception list in WinDBG. But just remember, exceptions are actually raised twice if they are .NET. So trap the native exception, but let the exception go if you see that the meaning of the exception is that it is going to be raised into .NET, and read the .NET version. Now, there's a few other techniques as well that I could have showed, but I didn't want to make this video way too long. But there are techniques to capture exceptions based on their name, which is also useful and also work in a mixed mode application. This application, which I use as an example, is written in .NET Framework 4. But I know that the underlying is native C++, hence I use the underlying native C++ to manipulate the exceptions so that WinDBG could catch native exceptions. You will get the same problem if you write your own C++ modules and put them in .NET. The exceptions don't change as long as native exceptions are raised by a native module and they flow into .NET. You will get this peculiar sequence in which the native exception is raised first and then the .NET CLR exception is raised second. I use these techniques daily because the applications that I work on often have COM or often have native modules that have to be embedded into .NET modules. So I use WinDBG exclusively for exception handling because Visual Studio kind of suffers if you do not have all the symbols or all the source code. It's kind of hard to use Visual Studio, but in WinDBG it's pretty simple even though it is a mixed mode application. Anyway, that's quite a lot. So let's end this video over here. Let me know in the comments below if you have used any of these techniques before. Gentle reminder to subscribe, hit that bell icon and give a like if you like the content. As always, it's been a pleasure bringing you this information. I am High Voice, signing out.